All right, let's look at having expressions like this. Oh, my word. We're looking at the nth root, and I want to make sure you know what you can and can't do with some of this stuff. First, we're going to look at what happens if that index is even. You have an even index, okay? That means that the radicand, the stuff inside, must be non-negative. The radicand must be non-negative. Okay, if this is an even index, you can't plug in negative numbers. Okay. It's like radical, except without an L, it's an ND. Remember, the radicand can, 'cause he mixes it with love and makes the world taste good. Here's something else that we should know. The nth root of a to the n is the absolute value of a.
Non-negative, why would you say must be positive?
Because it could also be 0. 0 is neither negative nor positive, so we say non-negative.
Oh, okay.
Any other questions you would like to ask?
Oh, okay.
Because we're recording right now.
When if we're recording, that was a good question, because somebody could have thought of it.
Yeah, yeah, they all think of that stuff, don't they? If n is odd, then what do we know? Well, a can be any real number. A can be any real number, either positive or negative or 0.
Awesome.
The domain is everything. And that means that the nth root of a to the nth in this case is going to be a without the absolute values. We're going to show you why the absolute values are necessary here in just a moment. Okay? So that's the distinction we have between if it's an even or an odd index. Okay? So let me just work through some of these. I just want to show you a few examples of how this stuff comes into play. So if I ask you to simplify, and I say, let's start off nice and easy. What's the square root of 193 squared? Well, since notice there's no index written here. If it's just the square root symbol, it's understood to be an index of 2. Okay? So since the index and the power match up, then this should equal the absolute value of 193, and of course that's just 193. You may still be wondering that absolute value doesn't really mean anything. Hold on. If I have the 7th root of 82 to the 7th power, what should that answer be? What?
So should we do the absolute value first and then do the set?
But notice, the index and the power are the same, but they're both odd. So in that case, it's just the base. That's your answer. So the answer is just 82. It doesn't make any sense. So what you're actually answering here is, I'm saying what to the 7th power is equal to 82 to the 7th power.
Why would you even ask a question like that? I'm sorry, but why would you ask that question? Okay, what to the 7th power equals 82 to the 7th power equals 82 to the 7th power?
So you know the answer here is 82, right? So if you see something like this, and these guys are the same, you don't actually work out 82 to the 7th power, because it's going to be a waste of time. Now if I have this, if I have the 12th root of negative 19 to the 12th power, notice how the index and the power match up, right? Y'all agree with me on that? The answer a lot of students would want to say is negative 19, but that's not right. It's the absolute value of negative 19, which of course just equals 19. And you may say, why do I need that absolute value? Okay. Well, think about this. If you just wrote negative 19, that's going to be wrong. Okay? Because if you were to do the order of operations first, if you were to raise negative 19 to the 12th power, what would be the sign of the result?
Positive.
Positive. What's up? And what's the 12th root of a positive number? It's going to have to be positive, right? If this guy right here ends up being just a positive number, all of this stuff right here is equal to some positive number, right? Then when you take the radical of that, the 12th root or whatever it is, it has to be a positive number. Right? However, if I have the 53rd power, or excuse me, 53rd root of negative, I keep using the same numbers. It's like I can't even break free from this. Negative 853 to the 854 to the 53rd power. Notice how the exponent and the index match up, right? Now, since this is odd, what would happen if you took a negative to an odd power? What would you get? You get a negative number, right? And the 53rd root of a negative number is going to give you a negative number. So the answer here is just negative 854. What I don't want you to do is to try to figure out what is 854 to the 53rd power. It's going to be a waste of your time. You do not want that.